Hello everyone. In this video, I'm going to talk about the implicit differentiation. But before we talk about implicit differentiation, let's talk about our chain rule. So previously we learned that the chain rule is applied when we have composite function. So for example, if y is a function of u and u in turn is a function of x, then we say that y is a composite function of x. So y is a function of x. But if you want to take the derivative of y with respect to x, so first we need to take the derivative of y with respect to u, and then we take the derivative of u with respect to x. So algebraically, we have this for our chain rule. And we also learned another hack for the chain rule. Like if you have derivative of something raised to power n, the outside function is the power function, and then inside you have something. So what we do in that case, first we apply the power rule. So something raised to power n, so derivative would be n, bring the power down, that's something raised to power, reduce the power by 1, and then derivative of inside. So d outside times, so derivative of outside times derivative of inside. That was our another way to remember the chain rule. All right, so let's take a look at these functions here. So we have, so let's talk about implicit and explicit functions. So if you are given everything of x and y together, so this equation defines a function, and if we try to solve this for y, let's see if we can isolate y or not. So in this case, negative 4y is equal to 16 minus 12x, and we get y is equal to, so dividing both sides by negative 4 plus 3x. So this is our explicit function because we can write y in the form, so y as a function of x. So again, let's take a look here. So here we can split p. So we can write p as v over 12 again. So or v as 12 over p. Again, these are explicit functions because we don't have any mixed terms on the other side. Similarly, for the last one, we can write y is equal to 16 minus x squared, and then we can split y as square root of 16 minus x squared. So again, this is an explicit function. But what about the next case? We have x squared y cubed plus 4y minus 3x plus xy equal to 0. So here you can see that we have some cubic terms of y, some linear terms of y. So it's not really feasible for us to put y explicitly in terms of x. So in this case, it means we need to develop a different method to take the derivative. And that new method that we're gonna learn to take the derivative of this kind of function is called implicit differentiation method. For implicit differentiation, we're gonna use some special cases of chain rule. So algebraically, we know that chain rule is, so derivative of y with respect to x is derivative of y with respect to u and derivative of u with respect to x. Or in symbolically, we can have something raised to power n, and first we use the power rule and then we take the derivative of that something with respect to x. So let's start with the simplest case, the simple expression x. So let's say that something is x, the box is x. So in that case, we have derivative of x raised to power n. So first we take derivative of outside, so n x raised to power n minus 1, and then the derivative of inside with respect to x. And in this case, dx over dx is just 1. So we get n x raised to power n minus 1. So derivative of x raised to power n is this. So this is our power rule that we have learned already. And we notice that here we have derivative with respect to x, and also the variable inside was simply x. So we don't need anything extra because we just cancel that dx over dx and we are just left with this. So this is our power rule. But what if we have some other variable? So let's say our that box thingy is y. So if you want to take the derivative of y raised to power n. First thing we notice that, so we are taking the derivative with respect to x, but here we have variable y, and y is implicitly a function of x. So in that case, using the chain rule, so first we do the derivative of outside, so we apply the chain rule power, and then take the derivative of inside. So what we get here is n y raised to power n minus 1 and dy over dx. So there is a new term in our power rule. So if you have a different variable in place of x, so you get a new term in the power rule, because by using the chain rule, you need to take the derivative of that inside with respect to x. So let's do an example. So for example, let's say you need to find the derivative of y raised to power 4. So in this case, so first we apply, so derivative of outside function, which is our power function. So this will become 4 y raised to power 3. And then by chain rule, the derivative of y. So in other words, we get 4y cubed y prime. So this is the most important thing that we don't want to forget while using the implicit differentiation. So whenever y is an implicit function of x, and we to differentiate with respect to x. So don't forget to add another y prime or dy over dx while doing the differentiation. So let's do a few problems using our implicit differentiation. So first thing is, so whenever you have an implicit equation, first step is differentiate both sides of the equation with respect to x, and then the second step is isolate dy over dx, because our goal is to find dy over dx. So in this case, we have this equation 4x minus 3y equals to 15. So you can do this either explicitly, because here you can write y as in terms of x only. So this equation can be an explicit equation if you want to. Otherwise, you can just use the rules of implicit differentiation. So I'm just going to show you how to do this using implicit differentiation. So first step is differentiate both sides of the equation with respect to x. So it means differentiate each term with respect to x. So both sides means each term of both sides. And now we know that derivative of 4x is just 4, and 3 is a scalar. So derivative of y with respect to x would be dy over dx, and derivative of constant is 0. And now we're going to isolate dy over dx, because our goal is to find dy, right, y prime. So in this case, so 3 dy over dx is equal to 4, or dy over dx is equal to 4 over 3, or in other terms, y dash is equal to 4 over 3. So this is the method when we used implicit differentiation. You could have done the same problem using explicit form. So using explicit form, we know that from here y is equal to 4x minus 15 divided by 3, or in other words, y is equal to 4x over 3 minus 5. So now if you take the derivative on both sides, so dy over dx would be, so 4 over 3 is a scalar, dx over dx is just 1, and then minus 0. So we get the same answer. Let's do a few more examples. So again, the first step is in this one, take the derivative on both sides with respect to x. So it means take the derivative of each term with respect to x, and derivative of x squared would be 2x, because we notice that this and this variable is same. In the next one, and if you just write dx over dx, it's not going to make a difference, it's just 1. Plus, now we notice that here we have x, but here we have y. We don't have the same variable. So first we're going to take the derivative. We're going to use our power rule, but now we're going to use our special power rule. So we're also going to add a dy over dx, and then derivative of 4 is 0. Derivative of a constant is 0. And now our goal is to isolate dy over dx. So in the next step, we write 2y. So if you want, you can just write the short form, y dash. Remember, this is just another way of writing dy over dx. It's just different notation. So in this case, we get negative 2x. And since our goal is to find the derivative, so 2 and 2 cancel, so y is negative x over y. So this is the slope of tangent at any point of the circle. So because this is the equation of the circle. So this is the slope function. All right, so let's take a look at next one. So we have x times y equals to 10. So again, first step is take the derivative of on both sides. So again, I just want to make sure that you know that this one can be written in the explicit form, and you can, if you want, you can use the other method. But I'm using the implicit method here. So here we have, so x and y. So whenever you have x and y terms together, for the mixed terms, you're going to use the product rule. So this is your u times v. So always use the product rule when you have mixed terms of x and y. So let me remind you, the product rule was, so if you had taking the derivative of product where u and v are the functions of x, so then first function as it is, derivative of second, plus second function as it is, derivative of first. Or you can sing your song 1d2 plus 2d1. Yeah, so in this case you can consider u as x and v as y. So it means the derivative of u would be 1 and the derivative of v would be dy over dx, which is y prime. Okay, so first function as it is, derivative of second, plus second function as it is, derivative of first, which is just 1. And on the other side we get derivative of constant is 0. Since our goal is to find dy over dx or y prime, so we get, gonna isolate it, so bring everything else on the other side. So we get derivative is equal to negative y over x. So let's take a look at this example. This looks a little bit more complicated than the previous one. In this one, we cannot write y explicitly in terms of x. So first thing that I want to point out, that remember, whenever you have a mixed term like xy term, we gonna use the product rule and you will get two terms after the differentiation. And similarly, whenever you have a y term, you always need to add a y dash. So let's try this one. So first step is taking derivative on both sides. So take the derivative of each term on both sides. And I'm just going to rewrite the whole step. Minus derivative of 12. So derivative of 3x with respect to x. So this is x, this is x. So it's just 3 dx over dx, which is just 3. And then 4 is a scalar multiple, so it can come out. So derivative of y squared with respect to x is going to be 2y. And don't forget dy over dx. Similarly, here 5 is a scalar multiple and we need to take the derivative of x times y square. So this is a mixed term, so we're gonna use product rule for xy square. So first term as it is, derivative of second, so derivative of y square would be 2y, y dash, plus second term as it is, derivative of first, derivative of x is just 1 and then minus 0. So we got 3 plus 8y, y dash and 10xy, y dash plus 5y square. So our goal is to isolate y prime. So we're gonna find this. So we're gonna isolate y prime. So it means the terms containing y dash gonna go on one side and everything else gonna go on the other side. All right, so from here y dash is a common factor. Inside we have 8y minus 10xy, 5y square minus 3. Thus, y prime is 5y square minus 3 over 8y minus 10xy. So this is our required solution. So just don't forget that whenever you have a mixed term, you're going to apply the product rule. All right, so in the next one, again, we need to find the derivative of y with respect to x. So first step is take the derivative with respect to x on both sides of the equation. So it means take the derivative of each term. And then we got, so derivative of x and x cubed. So x cubed would be 3x squared. Derivative of y raised to power 4. So here we have x, here we have y, so we have a different variable. So we need to apply the chain rule, so be very careful. So we have 4y cubed and then dy over dx. And similarly, we have 3 times dy over dx. And our goal is to find y prime. So bring the terms containing y prime on one side and everything else on other side. So it means we have 4y cubed y prime minus 3y prime is equal to negative 3x squared. And this is a common factor. And our goal is to isolate y prime. So in the end, we get negative 3x squared over 4y cubed minus 3. So for implicit differentiation, so first step is take the derivative of both sides with respect to x, and then the second step is isolate the terms of dy over dx. And remember, if there are any xy terms, you use the product rule. I hope you enjoyed this video. Please keep practicing and happy studying.